Hi everyone, I'm Edward and I'm a solutions architect here at Striim. Thanks for joining us in this tutorial of how to migrate your on-premises or other cloud Postgres database to GCP Cloud SQL for Postgres with zero downtime. Now this tutorial makes some assumptions and that you have already deployed Striim through the GCP marketplace, have a source PostgreSQL database configured with a user with read privileges. Please reference our documentation at docs.striim.com to do so, and a target Cloud SQL for Postgres database already configured. Additionally, this is a great time to think about networking. You'll need to be able to connect from Striim to both your source and target databases. We suggest to reach out to your GCP contacts to configure a cloud interconnect or a VPN so that you can connect with private IPs. Before we dive in, let's talk briefly about zero downtime or online database migrations. An online database migration consists of two processes: an initial load process to capture a snapshot of your database at a single point in time, and a log-based change data capture process to continuously capture all of the inserts, updates, and deletes that occur on your source database while the initial load is propagating. During this guide, we'll first build and test an initial load application, then the CDC application, and finally we'll execute an end-to-end database migration, including schema migration. With that said, let's dive in. So here we are at Striim's UI, and all I've done is log in. So if you deployed Striim through one of the metered solutions in the marketplace, your temporary admin password is located in the deployment manager, so just enter admin as your username and that temporary admin password as your password. So here we are at the home screen, and here you have three different panes. On the left-hand side is the dashboarding pane. So along with moving data in real time, you can also visualize it. People typically use these dashboards for things like data validation and verification. And all of these dashboards are created with drag and drop widgets and then populated with simple SQL queries. In the middle, we have the applications pane. So what we call applications are all of your individual data pipelines or data flows from a source to a target. And this is the primary pane that we'll be dealing with today. Lastly, there's source preview, so you can preview your data before moving it. So if we dive into the applications pane, you may see some preloaded sample applications here, depending on how you deployed Striim. But go ahead and click in the Add App button in the upper right-hand corner. So again, here you have a few different options. You could click Start with Template to go through the wizard-based development, where you just enter your various configuration properties of your source and target databases, and Striim will create the applications for you. You have the Start from Scratch, so this is the typical drag and drop UI that we'll be using today. And lastly, you can import an existing app. So all of the applications in Striim's UI are backed by what we call a TQL file, which essentially looks like PL SQL. And this is how you can create more of a managed service around Striim by programmatically creating those TQL files, and then you can even use a REST API to deploy and start your Striim applications. But today, just go ahead and click Start from Scratch to continue with the drag and drop interface. So go ahead and give your application a name. In this case, we'll choose PostgreSQL to Cloud SQL init load. And then choose a namespace. So namespaces are logical groupings of applications within Striim, and you can use them to create more of a microservices approach where you have one Striim application that reads from your source and a separate Striim application that writes to your target. Just go ahead and select the default admin for now, and go ahead and click Save in the lower right-hand corner. So this brings you to the typical drag and drop interface, which is what you'll be interacting with primarily to create all of your streaming applications. So in order to do the initial load, we'll use a component called a database reader. So just go ahead and drag and drop the database reader component onto the main flow designer. And this database reader is used for the initial loads to capture a snapshot of your database at a single point in time. So give this source a name. We'll choose PostgreSQL init load source. Make sure you're using the database reader adapter, and then provide the JDBC connection string for your source Postgres database. If you just hover over this tooltip right here, you can copy and paste from the JDBC connection string here. But in this case, I've already created my JDBC connection string, so I'll go ahead and copy that from off screen. Then provide a username and a password with read privileges on your source database. There are additional information located in our documentation, which you can just click this view documentation button, or you can go to docs.striim.com and just search for database reader. Then click on show optional properties to expose additional properties. Here in the tables property, specify a single table or multiple test tables that don't have that much data in them. So in this case, we have a sample line item table from the TPCH schema that contains 1,000,000 rows. So here, if you have multiple tables, you can manually specify them, or if you wanted to capture all of the tables within the public schema, you can also use wildcards. So you could say public.% to capture all of the tables within the public schema. In this case, we'll just choose a single line item table. And then the only other thing here that I'll change is I'll increase the fetch size to 10,000. Because we have 1,000,000 rows in that source table, 10,000 is a pretty good starting point for larger tables. Then we'll go ahead and give this output stream a name. Typical naming convention is you can just copy and paste the name of your source and then append _stream to the end of it. Go ahead and click save to save this component. And then before we continue, let's go ahead and make sure that we can actually read from your source database. So here, this just ensures that if there are any errors on the source, that means that it's something going on with the source database, nothing to do with the target database. So it's just good whenever you're creating your applications to test each individual step of the data pipeline. So go up here to the gray created button, click deploy app, click the blue deploy button to use the default deployment topology. Then go ahead and click the stream. So that's the circle with the wave icon right here in the middle of the page. And click the I button directly to the right of it to bring up the preview window. Then go back up here in the middle of the page, click on deployed, and click start app. So now you can see that we're successfully reading from our source database. We're capturing all those fields from that line item table, as well as the associated metadata. And when you have more complicated applications, this preview window is really helpful to ensure that your data is in the right format at every step of the pipeline. To capture some additional metrics, you can also go up to here to this speedometer icon and click on the See Application Progress. And you can see that we've successfully read all 1,000,000 rows of our source database. So there are 1,000,000 total rows. We've read all of them. And because we haven't connected a target yet, there aren't any targets here. So we'll go ahead and click OK. So now this means that we can successfully read from our source database. So we can continue and add a database writer target. So we'll go ahead and stop the application. and then go back up here to the stop button and click undeploy app to be able to edit it and add your target. Click on the Striim icon again and click on the plus button directly to the right of it. Click on Connect Next Target component to connect your target. Give this target a name. We'll say Cloud SQL PostgreSQL init load target. Make sure the input stream is that of the source database reader, and type database in the adapter field to pull up database writer. So this is just the component that we use to write to your target database. Here, specify all of the connection information of your target Cloud SQL for Postgres database. So in this case, we've already built our JDBC connection URL. This can just be found in the Cloud SQL portal. So we'll go ahead and copy and paste that. Make sure you append the string type equals unspecified to the end of your JDBC connection URL. Provide a user and password that has write privileges to your target database. And then specify the tables property. So here, the syntax is source target pairs. So in this case, we had a source public.lineItem table, and we want to map that to a target public.lineItem table. In reality, you would use wildcards here. So you would say public.%, comma, public.%, to migrate all of the tables within the public schema. Or you can also specify multiple tables manually. So you could say public.lineItem, public.lineItem, and say you had an orders table, then you would also add semicolon public.orders, comma, public.orders. Go ahead and click on the blue Show Optional Properties here to expose additional properties. Here, there's some things to note, primarily the batch policy and commit policy. So underneath the covers, Striim creates micro batches of your events because it's much more performant to apply 1,000 or 10,000 events at a time rather than saying insert ID1, insert ID2, and so on. So if you have a large data set, we suggest to increase the batch policy and commit policy. I'll specify event count 10,000, interval 1, although you can specify others depending on your data set size. An additional property to note here is this parallel threads property. So underneath the covers, Striim parallelizes the initial load process to ensure that it goes as fast as possible. So here, depending on the size of the underlying VM that you're running Striim on, specify the number of vCPUs. So in this case, I'm running Striim on an 8 vCPU system, so I'll specify 8 and the parallel threads property. Then I'll go ahead and click Save. So now let's go ahead and test that the initial load works. So go back up into the top middle of the page, click the Created button, click Deploy App. Again, click the default deployment topology. Just go ahead and click Deploy. Click the Striim icon, then the I button right next to it, and click Start App. So now you can see that, again, Striim is successfully reading from our source line item table and writing out to our Cloud SQL for Postgres instance. So here you can dive in, make sure all of your data is previewed successfully. And again, we'll just go up here to the application progress window to get an overall view of how far along our initial load is. So here you can see that we've read about 770,000 records, no, 970,000 records, output about 908,000, And now you can see that our database migration is complete. So we'll go ahead and click OK, and then just go to our target Cloud SQL for Postgres instance to verify. So here, all we've done is connected via the Cloud Shell to our Cloud SQL for Postgres target database. We'll go ahead and run the select count star from line item query, and you can see that all 1,000,000 rows have successfully landed in our target database. So now if we go back to Striim, we've successfully tested our initial load and confirmed that Striim can connect to your source and target database and run the initial load. So now let's go ahead and create the CDC pipeline. Go ahead and navigate up to the main menu bar and click on Apps to go back to the main Applications page. Again, click on that blue Add App button in the upper right-hand corner and click on Start from Scratch to develop using Striim's drag and drop UI. Provide this application a name. We'll choose PostgreSQL to Cloud SQL CDC and select a namespace. In this case, we'll use the default admin namespace again. Click Save to create your application. And this time, instead of using a database reader component, we'll use the PostgreSQL reader. So you can either search for that up here in this menu bar or scroll down in the sources until you reach PostgreSQL CDC. Drag and drop the PostgreSQL CDC adapter onto your flow designer and provide the source a name. We'll say PostgreSQL CDC source. Provide a JDBC connection URL. Again, you can hover over this tooltip, copy and paste, and then enter your various IP address, port, and database name. But we've already constructed our JDBC connection string, so we'll just go ahead and paste that here. Provide a username as well as a password for a user that has the correct privileges for the CDC application. You can find those in our documentation at docs.striim.com or by clicking this link right here. Provide a table that you want to test with. We said just to use a subset, maybe 5 or so tables that are representative of your overall database. In this case, I just have a simple orders table that I'll go ahead and use for testing purposes. Here, again, you can specify individual tables or use wildcards such as public.%sign to capture all of the tables within the public schema. Provide the replication slot name that you created in our PostgreSQL setup in the documentation. And go ahead and click on Show Optional Properties. Here we won't change anything right now, but I just want to note the Start LSN property, since we'll be using it later in the end-to-end migration to coordinate the initial load and CDC processes. But for now, just leave it blank. Then go ahead and provide an output stream name. We'll go ahead and copy and paste the source name underscore stream. Click on Save to save this component. And again, let's go ahead and test before continuing to make sure that we set up CDC correctly on our source database and that everything works correctly. Go back up to this gray Created button, click on Deploy App, click on the default deployment topology, and click Deploy. Click on the stream, click on the I button next to it to bring up the preview window. Click up here at Deployed again, and click on Start App. So here, unless you have an active source database, you won't actually see any data flowing through, since by default, with the CDC application, Striim only looks for new changes, so new inserts, updates, and deletes on your source table. In this case, we have a data generator that executes a whole bunch of inserts, updates, and deletes on that orders table. So I'll go ahead and start that now. And now you can see that we're successfully reading our source Postgres database, and we're picking up all those changes that our data generator is generating. So here we have all those fields from that orders table, as well as the associated metadata. Again, you can go ahead and click up here in the upper right-hand corner, click on this See Application Progress window to see additional metrics about your source. You can see that we've ingested so far about 5,500 records, and in this case we don't have an output, so we aren't outputting anything. So now that we've tested that we can successfully read from our source Postgres database via CDC, we can go ahead and add our target Cloud SQL for Postgres instance. So let's go ahead and stop this application, undeploy, click on the Striim, and then click on that plus button to connect your next target component. Give your target a name. We'll call it Cloud SQL PostgreSQL CDC target. Go ahead and type database in here in the adapter to select your database writer target, and then provide all of your JDBC connection information. In this case, we've already built our JDBC connection string, so I'll go ahead and copy and paste that from off screen. Provide a username and a password that has write privileges to this database. And then specify the tables. So here again we have that source public.orders table that we want to map to our target public.orders table. Again, if you wanted to specify more tables within that public schema, you could either manually specify all of them, or you could say public.%, public.% to migrate all of the tables within your public schema. Again, you can click on Show Optional Properties to expose some additional properties. Here, we'll leave everything the same, but just note that with the default batch policy and commit policy, if your source database isn't generating that much data, you may have to wait 60 seconds to see your data propagated to the target. So go ahead and click Save to save this application. And then let's go ahead and deploy and run to test that this application works successfully. So go ahead and go back up into the top middle of the page, click that Created button, click Deploy App, click the default deployment topology, and click Deploy. Striim will validate to make sure that your source and target schemas match. And then go ahead and start your application. Again, if you don't have any new changes coming in on your source database, you won't see anything flow through. So we'll go ahead and start our data generator. And now you can see that again, data is flowing through Striim, and we're capturing those orders fields as well as the associated metadata. If we go up here and click on Show Application Progress, you can see that we're successfully writing out to our target Cloud SQL for Postgres instance. Lastly, let's go ahead and query our target instance just to make sure that our data has successfully landed. So I'll just run a simple select count star from our orders table, and you can see that we have 3,425 records in it. So Striim's continuously outputting new data to our target orders table. So if we go back to Striim, while we're running the CDC application, I'd like to quickly show some of the various monitoring metrics that you can utilize. So if you go up here to the configuration wheel and click on Monitor, you can dive into the application's monitoring pane. So in this left-hand menu bar, you can take a look at each individual step of your application. You can take a look at your sources, click on More Details to see more details. If you had any queries, you could take a look at your queries, things like query performance. Take a look at your targets. Make sure the amount of events in equal the amount of events out. You can dive into the end-to-end lag to see the amount of time that it takes from Striim reading a record on your source to it being output on your target, as well as dive into more details to really get a good sense of what's going on your target database. Things like table info, so you can see that we have a relatively insert-heavy load with some updates and deletes. And all of these metrics are accessible via REST API, so typically customers will integrate them into their existing monitoring metrics. So now that we've gone over some of the monitoring aspects, let's go ahead and create the end-to-end database migration. Before we continue, now's a great time to talk about the end-to-end migration process. So what we've done so far is we've built and tested an initial load application as well as a CDC application. However, they aren't coordinated. So in order to execute an end-to-end migration, the first step is to migrate your schema. Today we'll show how to do it using Striim's schema conversion utility, but you can also use tools such as pgdump and restore. Just make sure that before you execute the initial load, foreign key constraints are turned off on your target database. Striim's schema conversion utility does it for you, but if you use external tools, just make sure to do that. Unlike CDC applications, which propagate events in the order that they occur on the source, with initial load applications, there's no way to enforce foreign key restraints. Once you've created your target tables, we'll show you how to do that in a minute with Striim's schema conversion utility. The next step is to capture the LSN of your source Postgres database by executing a simple query on your source. We'll link to our documentation as well as show how to do that in a minute. Then we'll edit any required properties of the initial load application and run it. Once the initial load is complete, we'll turn on any foreign key restraints that you turned off earlier or didn't apply earlier. And finally, we'll edit the CDC application to start from the LSN that you captured earlier, as well as add some additional properties to ensure exactly once processing guarantees. So here we are at the underlying Striim VM. All we've done is we've SSH'd into the VM by clicking on the SSH button within the Google Cloud Console. First, let's go ahead and change directories to our main/opt/Striim directory. Then we'll go ahead and run our schema conversion utility script. All the various properties are located in our documentation, so please just change them to point to your source database. So here we've already created this the script. All we're going to do is point to our source database, and we want to migrate the public schema. So we'll go ahead and run the schema conversion utility. So then Striim comes back. We see that there are 3 tables within that public schema. All of our tables are compatible out of the box since we're going from Postgres to Postgres. There shouldn't be too many issues. If there was anything that might not be compatible, that would show up either in number of tables compatible with Striim Intelligence or a number of failed tables. Additionally, since we're working with a demo dataset, we don't have foreign keys, but in your case, you would have the number of successful foreign keys migrated, which would pop up with an additional SQL file. So let's go ahead and navigate to the output of our schema conversion utility. So we'll just go ahead and change directories to our output. Then we'll do a quick ls, and you can see that we have two files. We have our conversion report, as well as converted tables.sql. Here, you may have some additional files based off of your data types. So let's just go ahead and take a look at our conversion report. And here we can take a look, dive in, make sure everything was converted successfully. Here we have a source Postgres database. We're going to target Postgres. All three of our tables have been converted successfully. We can dive in, see which tables were converted. And then also you can take a look at the actual converted tables.sql file if you'd like. Then the next step is to actually apply your converted tables.sql file on your target Cloud SQL for Postgres database. So the easiest way that we've found how to do this is by using the import button within the Cloud SQL portal. So if you just go ahead and upload the converted tables.sql file to a cloud storage bucket, which your Cloud SQL instance has access to, then you can just go ahead and click import and easily import all of your tables. So now that we've successfully migrated our schema, we'll go ahead and dive back into Striim, make some quick edits to our Striim applications, and then go ahead and execute the end-to-end migration. Before getting back into Striim, first, let's go ahead and connect to our source Postgres database. Here I'm just using pgadmin, but you can use any SQL query tool that you prefer. Here we're going to execute a simple query to capture the current LSN on our source database. If your source database is Postgres 9.6 or lower, use this query. And if it's 10 or higher, like we have today, go ahead and execute this query. So we'll go ahead and execute this query, and you can see that it responded with this LSN. So we're going to copy and paste this LSN into any Notes app that you prefer, just to write it down for use in the future CDC application. So now that we've successfully captured our source LSN, we'll go ahead and dive back into Striim. So if we switch back over to our initial load application, and here we're just going to edit a few quick properties to point to our production database. So go ahead and click on your database reader. Here, change this connection URL, username, and password to point to your other database, or if you're using the same database for testing, go ahead and keep that the same. And then you may want to change your tables property to include additional tables. Lastly, go ahead and change the fetch size. If you were testing with some small tables, you may have had that at a lower value. So here, just go ahead and increase it to 10,000 by default. And go ahead and turn on QuiES on initial load completion so we can easily see once the initial load is done. Go ahead and click Save to save the component. And then we'll go ahead and click on our target database router. Again, go ahead and edit the connection URL to perhaps point to a different target Cloud SQL for Postgres database. Modify the tables property accordingly, perhaps public.%, public.%, to capture all of those tables within a single schema. And then also just click on Show Optional Properties to expose some additional properties. Modify the batch policy and commit policy. And then additionally, utilize the parallel threads property to parallelize the initial load across how many cores of Striim that you're running. In this case, we don't have a large source database, so we'll keep it at 8. But if you're moving a lot of data, I would highly suggest to increase your Striim VM for the initial load, perhaps even to 16 cores. Go ahead and click Save if you modified anything here, and then deploy and run the application. Wait for this application to complete. You'll see a Quiesced setting up here. And then we'll go ahead and go to our CDC application and make some final changes to point to that LSN that we captured previously. Now that we've completed our initial load application, we can continue with modifying our CDC application. So all I've done is I've navigated to our CDC application from the main apps page, and go ahead and click on your source to edit a few of the properties. Again, just like your initial load, modify the connection URL, username, and password if you're connecting to a different database. Go ahead and modify the tables property as needed to perhaps point to a different schema. And then click on Show Optional Properties. Here, it's really important to copy and paste that start LSN that you captured earlier. Then we'll go ahead and go to our target database writer. Again, modify the connection URL if you're writing out to a new Cloud SQL for Postgres database. Perhaps change the tables property if you're using a different schema. And again, click on the Show Optional Properties. So here, modify the batch policy and commit policy as needed based on your data. Additionally, enter in the ignorable exception codes of 23505, no op update, and no op delete. So because we're pointing the CDC application to before the initial load started, there may be duplicates that were already written out by the initial load application. So we just want Striim to ignore those errors and continue processing. However, we'll go ahead and do something here in a minute, which allows you to write them out to an exception store, and then you can always process those events after the fact. Go ahead and click Save here to save your target database writer. And then go up here in the upper right-hand corner and click on Exceptions. And click on Turn On. So this just allows Striim to track all of those exceptions that we're ignoring as per the ignorable exception code that we just entered. And you can always read from these after the fact and process them however you'd like. Additionally, we need to make sure to turn checkpointing on so that if this application crashes for some reason, or even if the Striim VM goes down, this ensures that Striim can pick up from the last known good read checkpoint, and it knows the last known good written checkpoint. And then we can coordinate the two to ensure exactly one's processing guarantees. So go ahead and click up here into the configuration wheel and click on App Settings. Go ahead and enter an interval in the recovery interval. We'll link to the documentation again for this to figure out the most optimal recovery interval for your data set. But here for this demo, we'll just select 30 seconds. Then we'll go ahead and click Save. So perfect. Now you're good to go, and you can go ahead and deploy and run this application just like the other applications that we were working with. And you will now be able to keep your source on-premises or other cloud Postgres database continuously in sync with Cloud SQL for Postgres. Please reach out to us at partners@striim.com if you have any questions. We're happy to provide an assessment of your use case and answer any of your questions. Hopefully this was helpful, and thanks for watching.